All right, this is AP Calculus AB Self-Check 9.3. Today's date is Monday, February 10th, 2020. Yeah, let's get right into it. So I would give yourself 15 minutes if you can, 10 minutes if you can't to do this problem. This is a heavily modified version of an actual AP problem. So rocket A has this velocity at those times every 10 seconds. All right, so part A, let's find the average acceleration. If it says average of anything, you should be thinking integral with a fraction. So integral with a fraction, that's going to be integral from 0 to 80, 0 to 80 of whatever it's talking about. Acceleration, so it's going to be a of t dt. And then average is going to mean I'm going to have this all divided by 80 minus 0. And again, another way of writing that is 1 over 80 minus 0, or 1 over 80, right? So how do I do this problem without a calculator? Without a calculator, you say, okay, well, the antiderivative of acceleration is velocity. So this is going to be, copy down the 1/80th. I always forget that, so I try to remember that more and more. Antiderivative of acceleration is velocity of t. Evaluation bar between 0 and 80. That 1 over 80 is going to be multiplied kind of outside of the evaluation bar. That's the word I'm looking for. So this is now going to be equal to 1/80th of, start our parentheses here, it's going to be v of 80 minus v of 0. And that's going to be 1/80th. V of 80 is 49. 49 minus, and then v of 0 is 5. And let's see, 49 minus 5 is 44, so this is going to be equal to 44 over 80, and reduce that just a little bit. That's going to be, I don't know, divide the top and bottom by 4, I'm thinking 11 over 20. Yeah, okay. So 11 over 20, and our units, so it says indicate units of measure. Our units are, so it's whatever acceleration is. So if it says average of blank, the units are going to be whatever that blank is. So what are our units for acceleration? Acceleration is feet per second, or feet per second squared. All right, so part B, using correct unit, explain what that thing means. So I'll get my typing ready. This means the total change in whatever, in velocity. No, total change in, whatever the integral of velocity is. So total change in position, what are we going to call this? Height. This is launching up. Does it? Okay, I'm going to just say total change in distance. Total change in feet from time from t is equal to 10 seconds to 70 seconds. Perfect. Done. And then use a midpoint Riemann sum with 3 subintervals of equal length to approximate the integral from 10 to 70. Okay, so I remember doing this my first year. I totally made a mistake, and I did from 0 to 80. It's from 10 to 70. So 10 to 70 means from starting from here and ending here. If I do that, the way that midpoint works is you can kind of go crisscross, right? You do these values, then these values, then these values, and then I'm done. So crisscross, 30 minus 10 times 22. So we can say this is approximately equal to 30 minus 10, and times whatever the middle is, 22, the height of 22. Plus, and then it's going to be 50 minus 30, 50 minus 30 times the middle height there, which is 35. And by now you're probably seeing, hey, each of these intervals is the same. I wonder if the shortcut that we learned in Self-Check 9.2 still works, and the answer is yes. I'll go ahead and show you the shortcut in a sec. 70 minus 50, 70 minus 50 times the middle height of 44. And what is that going to be? So this is going to be equal to now, here's the shortcut method. Each of these is 20, 20, 20, 20, 20. So I kind of just factor out the 20. This is 20 factored out, and then what's left over, 22 plus 35 plus 44. All right, so doing some quick mental math. 35 and 44 is 79. which is basically 80. 80 plus 22 is 102, but minus the 1, so 101. So this is now, all right, 101 above this, and 101 times 20 will double this and then add a 0. So double 101, it's 202, and then add a 0. So this is equal to 202 with the 0, 2020. I can write that slightly neater. 2020, and that is the approximation. We should probably have our units here. So if it's the total change in feet, then this is the units of feet. Cool, again, I'll come back and score this later. Part C. And our final. Oh my gosh, we have square roots in the denominator and no calculator. Oh boy, all right, so this has an initial height of 0, so I'm thinking that's probably like a start condition. And initial velocity is 2, that's also kind of a start condition. Which of the two rockets is traveling faster at time is equal to 80? Well, how fast is rocket A going? Rocket A, this is rocket A, right? Rocket A is going, this is its velocity, at time is equal to, what is it again? Time is equal to 80? Well, time is equal to 80, we know rocket A is going 49. So I come back down here and say A of V of 80 is equal to 49. So we're comparing against 49. How do we find that with this one? It's going to be start plus change is equal to n type of thing. So what is its, we have to figure out what its velocity is from acceleration. We're only given acceleration, we have to get all the way back to velocity. So I'm going to take the integral. So we don't need to know the initial height though, do we? Which it's only asking about speed, so whoa, I think I might have to edit this because normally in an AP question, whatever information they're giving you, you should use, but I don't think we're using the fact that we start at 0 feet. Interesting. So we're talking about rocket B now. Let's do this in a different color. For rocket B, we know that it's going to be the, I guess we'll say at time t, it's going to be the start velocity plus the change in velocity will be the final, or end. I'll use the word end velocity. End velocity. And I can make this table look kind of formal here. Chunk, chunk, and chunk. So we're obviously doing that time is equal to 80. I don't know why I'm making a table. It's kind of silly of me. But at time is equal to 80. Our start velocity, what was our start velocity? Is 2. So our start velocity is 2. And then it's going to be the integral of acceleration. Between where and where? Between 0 seconds and 80 seconds of that acceleration thing. So this, I'm going to kind of rewrite it a little bit without a fraction. It's going to be 3 times t plus 1, all of this to the power of negative 1/2 dt. So if I figure out what this is, add 2 to it, then I'll get its end velocity, then I can compare it against 49, but I have to do a bit of math to do that. So here's my scratch work. I guess I could make these bars slightly smaller too. I didn't need all of this room taken up. So if I take the antiderivative, do I need to use Taxman? You can always use Taxman and you'll get the right answer, but inner is t plus 1, dinner is 1. I don't actually need to use Taxman. So the antiderivative, I'll say that the, here's our scratch work, 0 to 80 of, I can factor out that 3 too, I don't need it on the inside, of t plus 1, all of this to the power of negative 1/2. That's equal to, leave the 3 factored out, and it's going to be t plus 1. So it's going to go up a power to positive 1/2. Divide by 1/2 is the same thing as multiplying by 2. And evaluation bar between 0 and 80. All right, so what is this? And don't forget to add the 2 at the very end. I'm always going to try to remember that. When I plug in 80, I'm going to get 81. To the power of 1/2, that just really means this is being square rooted, and I can ignore the 1/2. So the square root of 81 is 9. So this right here is 9. I'm skipping too many steps, aren't I? So this is 6 times square root of 81 minus, I guess I can leave that 3 factored back in. I guess I'm leaving it there. Yeah, 6 times the square root of, when I plug in 0, 0 plus 1 is 1, square root of 1. Cool. So what is this thing? This thing becomes, that's going to be 9. That's going to be 9 times 6 is 54 minus 6. 54 minus 6 is 48. And oh, check it out. So you might think it's less. You might think, oh, the answer is 48, and 48 is less than 49. But we forgot to add the 2, which means the answer is 50, which is actually bigger than 49. They left it right on the edge there, so if you forgot the start condition, you would get the wrong answer. Very interesting. Probably makes it easier to grade too. I'm going to write the conclusion up here. No, hold on. I can shift some things around. Bear with me. So if I shift all of, grab the 80 to 9, or the 8. If I shift this right here, move this 8 back down here, and then move this all up, I'll have room to write the conclusion on the bottom, which makes more sense if you're looking at the static answer key without looking at the video. So I can come down here and I can now type in my answer. So what is it actually asking? Blah, blah, blah. Which of the two rockets is traveling faster? So rocket B is traveling faster at times equal to 80. Explain the answer, and we did all the math. Done. All right, so for scoring, it turns out there actually was a solution guide. It's from, the 2006, right? This is the right one. Yes, all right, so this is 2006, question number 4, version A. You get 1 point for part A if you just get the correct answer. Notice that units at the very end, if you get the units correct in both A and B, then you get the unit. If you miss it in A or miss it in B, then you lose the point. So for now, just give yourself +1 if you got 11 over 20. I guess I should be checking my work now too. This is going to be embarrassing if I get one of them wrong, but that's how you learn, right? Growth mindset. So +1 if you get the answer, that's out of 1 point. B, what do we got here? 1 point if you have an explanation, so it should be the distance in feet between time is equal to 1070. That's what we got, so give ourselves 1 point for the explanation. If you somehow use those V of 20, V of 40, V of 60, and that's what we have right here, 22, 35, and 44. If you have those 3 numbers, give yourself +1 point. And then finally getting the actual value of 2020, which we got correct. Woohoo! +1. Okay, so that's out of 3 points just for part B. And then there's 1 point if you got the units. So I'll say units in both A and in B. So now we're up to 3, 4, we're up to 5 points, which means there should be 4 points for part C. And if we check back down here, it is indeed 4 points. So if you somehow have 6 square root of t plus 1, so that's what happens when we took the antiderivative, which is right here. If you somehow took the antiderivative correctly before you plug everything in, you give yourself 1 point. Constant of integration. What does that mean? Plus c, but we know, that's the initial value, 2. Because we know what our plus c is +2. So give yourself 1 point if you somehow use 2. Use the, those are the same thing. Well, I guess you're going to get 2 points for the constant of integration, according to this guide, because your plus c is just your 2. And then finding that and comparing it and drawing a conclusion. So finding this 50, saying, hey, yes, 50 is bigger than 49, and therefore B is traveling faster. All of that together is +1. So the way I can show that in the static version, say here and here. If you gave the conclusion and got 50, give yourself +1. So giving ourselves 2 points there, by the way. That is out of 4 points, and 4, 5, 6, 7, 8, 9. That does indeed add up to 9. All right, so for self-check 9.4, our last self-check of our unit, we're talking about a test plane. It's flying with a velocity every minute, miles per minute, going very fast, not miles per hour, miles per minute. First, we're going to use a midpoint Riemann sum with 4 intervals from 0 to 40. So this whole thing is going to go with these diagonal values. So the way that we show that is we go from 0 to 10 times 9.2. And notice that each of these intervals is the same thing. So I'm going to kind of skip some work here. Each of these intervals is always 10, 10, 10, 10, and 10. So those are our 4 intervals that we're talking about. So each of those intervals, let's say that this integral from 0 to 40 of capital or lowercase v of t, this velocity of t dt, this is going to be approximated by 10, I'm factoring that out, times the height, the middle of the height, or the middle is going to be the midpoint, right? So 9.2, 7.0, 2.4, and 4.3. So I'm going to write those down. 9.2 plus 7.0 plus 2.4 plus 4.3. All right, so add all of these up, and I did this ahead of time, so this should be 10 times 22.9, 22.9. And that means that I don't know, I'm writing approximately equal to, these two statements are exactly equal to, oh gosh, did I kill the computer? These two statements are exactly equal to, and just move the decimal place, 229. So this was an integral of velocity. So integral means I'm getting rid of minute and I'm just talking about miles here. It's total unit or quantity of miles. 229 miles, and we'll box it. Show the computations that led to your answer. We did that using correct units. Explain the meaning of this. Okay, so this is where we can say this means the total distance traveled in miles from where to where? From 0 to 40 minutes. Done. How do we score ourselves? Let's see if I actually have a key this time. Yep. Okay, so this is the right question. This is 2004 Form B. So if it seemed hard, it's because it came from Form B. It's slightly harder. You get 3 points. One if you use V of 5, V of 15, V of 25, and V of 35. Those correct heights, which we did right here. Those are the ones I circled. So we give ourselves 1 point there. We also get 1 point if we got the answer, and 1 point if we got the mean. So 1 point if we got the answer of 229, and 1 point if we said something along the lines of total distance with all the units in there. So that's +1, and that's going to be out of 3. Part B. Based on the values of the table, what is the smallest number of instances at which the acceleration could be 0? This is a hard question. I haven't talked about it before. So what is going on? So I'm talking about acceleration, which is the derivative of velocity. So I'm talking about the slope of velocity. And as we all know, slope is equal to the rise or the run, or the delta y over delta x. So where do I have y values, or the same y values, or the same v values rather? So notice that this is in a different color. This 7.0 and this 7.0 are repeated, which means if I were to take this point 0.7 and this point 15.7 and find the average rate between those 2 points, that average rate is 0. And you might remember, oh yeah, average rate, that sounds like a theorem from our distant past called mean value theorem. If the average slope is 0, that means that that you must have at least 1 point in between 0 and 15 that also has a slope of 0, which is exactly what we're looking for. Acceleration is the slope of velocity, that is equal to 0. So really, this is a long-winded way of saying we're using mean value theorem on a few different values. So all you have to do for these problems when you see find acceleration or some sort of derivative, since we're velocity here, the derivative of velocity is acceleration, find two values of y, or v of t in this case, that are the same. Well, we also found others that are the same. Look at this. We have 2.4 and 2.4. Those are also the same, which means between this time 25 and this time 30, there must be at least, and there might be more, there must be at least one time where the acceleration is 0 by the mean value theorem. So how do we type that out? How do we write our answer? We say this. By mean value theorem, MVT, you can just abbreviate, v prime of t has to be 0 where? So is the interval between 0 to 15, so in 0 to 15, and what was the other interval? Between 25 and 30, and 25 and 30. Why? Okay, so we say because I guess we'll say because MVT says, okay, I'm gonna have to write this out. I don't know why I'm typing this. MVT says the following thing, that f of b minus f of a all over b minus a. That's our definition of what again? That's average rate. So I'm going to come down here. Just so I can zoom in here. I just wrote down average rate. Average rate. That's that equation right there. The average rate must be equal to the instantaneous rate, f prime of c, for some c in between a and b. And again, f prime of c, that is our instantaneous rate. Instantaneous rate. aka your acceleration. That's your acceleration. So my acceleration has to be equal to the average slope of velocity is what I'm really saying here. And that happens where for at least, and maybe more, 1c on a comma b. What did that? A comma b. Cool. Then we justified the answer. If you said somehow mean value theorem, then that's your justification. How do you score yourself? Yep, you have to say by mean value theorem and get those two instances. So if you say MVT, you get a point. If you find the other two instances, you get a point. So +1 for MVT, +1 for finding these two intervals. And I explained it way more than I needed to. I just write that one line and you're good. All that stuff is just for you guys to kind of understand what I'm talking about here. And I'll give you guys a heads up. You're going to be seeing this problem either on the pretest or the test or both, where I'm asking you to find some derivative that's equal to 0, where you will need to invoke mean value theorem. It does come back, although it's only like 2 points here, so it's not that big of a deal. You'll still get a 5 out of 5 on the AP test. Not knowing this information, it's just kind of nice to know. I'm on to part C. I have a function that's interesting. I guess I need to pull up my calculator. Let's come back here. Is it on? On. Turn on. Okay, let's clear out of that function. I guess I could have done this off camera. 6 plus cosine of t divided by 10, and the parentheses for cosine, plus 3 sine of 7t divided by 40. Don't need end parentheses. Okay, so I have my function. Let's get rid of all that other junk. Come back to the problem. That's used to model velocity. So this is a representation of velocity in miles per minute between 0 and 40 when what is the acceleration at t is equal to 23? Oh, okay, so I don't know if we needed to enter that into our equation because we need to find acceleration, right? So we're looking for a of t. What is a of t? A of t is really the derivative of velocity. So I say derivative of v prime of t, but they didn't say v prime of t. They gave us f of t. They should have really just given us, oh, because v of t is already defined to be this table value, so that's why they had to call it a different name. So that's, in our eyes, that's f prime of t, because f of t is this second velocity equation. And what is that? So we have to calculate this by hand, I think. Actually, there's a way to do it by purely calculator. So let me show you the shortcut, and then I'll do the long way. So say I have my equation, and I want to take the derivative and then find that value. So if I go here, I do math 8 of taking the derivative of var is right, enter 1, y1 with respect to x at what value? At time is equal to 23. 23. And I get negative 4.08. That's, I don't want to do this by hand. You could have done this by hand by taking the derivative and plugging everything in, and then eventually you would have had to actually calculate what cosine are. So I'm just gonna, I don't want to do the long way, I'm sorry. I'll just do it the short way. That's equal to, I'm gonna make a note to myself, math button 8, and then plug it in that way. And then you get the value negative 0.408, and what are our units here? It's miles per like minute or something, right? Miles per minute. Oh, this is acceleration. Acceleration is per time, so per minute squared. Cool. And yeah, let's, I did score part B. Let's score part C now. Oh, there it is, yeah. F of prime of 23 is blah, answer with units. Answer with units. Perfect, so that's going to be plus 1 point because we got the answer and we got the units. And then finally, part D, our last self-check question. According to that model that we just saw up here, so we did type in the equation, what is the average velocity of the plane in miles per minute? All right, so average of anything is always going to be the integral from wherever to wherever, so 0 to 40, because that's what it tells us for this interval. And then I'm always going to divide this by 40 minus 0, in this case just divided by 40. So I'm going to write this as divided by 40. Of whatever I'm talking about. Am I talking about average of velocity? Am I talking about average acceleration? Whatever this is the average between 0 and 40 of whatever I want now. So I want to find the average velocity, so I'm going to plug in velocity, and velocity is f, right? Otherwise, v would be talking about this table as I said earlier. So I'm coming down here and saying f of t dt. In miles per minute over, yeah, I think that's all we need to do. So this is a calculator problem, right? Okay, good. And it does match up with the calculator question. This is number 3. Oh boy. So I'm realizing that question 3 should be a no calculator question, but I was looking into this a little bit off camera and I don't understand. Like, if it is purely no calculator, there is no way that they are able to calculate the derivative of this. So I'm just gonna go ahead and assume here, yeah, just use a calculator. Do what I said. So use a calculator. So let's do this really quickly. This is gonna be, let's clear to this. Let's do 1/40th before I forget about 1/40th times, and this is gonna be math 9, the integral of vars, right? Enter, enter, y1 with respect to x from 0 to 40. And hit enter. That should be my final answer. It should be like 5.91. Yeah, 5.916. So this is 5.916, and this is an average velocity. So average of whatever, whatever is the units that I'm going to be talking about. So average velocity, my unit should be velocity, which is miles per minute. Cool. So let's come back here. How do we score part D? Part D is 1 for limits, 1 for integrand, 1 for answer. So you get 1 point if you just send it from 0 to 40, 1 for getting all this inside part, which is technically called the integrand, and 1 point for getting 5.916. That is a 6, not a weird 0. I can kind of add a tail to my 6. And that one's going to be out of 3 points, out of 3. There it is, out of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. It does indeed add up to 9, and that concludes self-check 9.4.